Hey everybody, and welcome back to the channel, and welcome to episode 30 of Project LS400. Now, Project LS400 isn't as much of a project that it used to be. Like I said in the previous episode, I want to now focus on smaller things I want to fix. I have some good news, I have a little bit of bad news, so let me get you up to speed. 2 days ago the car went up for its inspection and it went through with flying colors. There was only one small remark concerning the spare wheel. It didn't have enough pressure, so they corrected that, and other than that there were no faults with the car. I had the AC filled, so everything is working perfectly fine right now. The AC really cools great. It's amazing how well this AC works in this car. I will have the car aligned because I can feel it pulls a little bit to the right, but the tire shop is a bit busy, so I have an appointment for next week or a week later than that. Anyway, also the rattle in the front suspension is still there. As I said, I'm not going to look into that now, maybe over the winter time, but there's another larger issue that's a bit more concerning, and that's a fuel consumption. I've done 1,000 kilometers with the car, and the fuel consumption is at the moment 1 liter per 7.5 kilometers. I'll blink in the translation over here, where these cars normally would do 10 kilometers on 1 liter. Now, my previous LS got 8 kilometers a liter, was also on the, well, not too good side, so I want to look into that, and I have a suspicion what may be the cause of this, namely the O2 sensors. The car seems to be running rich, but the car has 4 O2 sensors, and I want to figure out which one that is. And to do that, we're gonna use the onboard diagnosis system. I do not have the tools, but I do have the workshop, and I'm gonna use the flash codes in the instrument panel to figure out what may be the case, what may be wrong with the car. So that's what's coming up in this episode. Okay, let's dive in the diagnostic system on board the Lexus LS400 for a moment before we start working. As you may have seen in the previous episode, I had to reset the fault code of the airbag warning light, and I did it via the OBD port in the dashboard. Now please note, this is not an OBD1 or OBD2 system where you connect a diagnostic tester and it gives a readout on there. This system works with flashing codes in the instrument panel. There is a diagnostic port, like I said, in the dashboard, and on the engine itself there's also a diagnostic port. But that port, let me show you. That port is located on here in front of the engine, and this port is more used to perform measurements and other diagnostics. It's not used to read out codes, but you're able to activate things like the fuel pump, for instance, which I did in an earlier episode, and you can also read out the voltages and the voltage swings of the O2 sensors. So that's what we're going to use. But before I can do that, I have to get the car in diagnostic mode and test mode, and it can also perform a recording session, which means you put the car in test mode and you go out for a drive, and the car has to meet certain standards like a coolant temperature and certain engine speed, so everything is warmed up and ready for normal use, so it's out of its warm-up phase. Then you can record it, go back, and then you can read out, and that's what you do via the OBD port in the dashboard. And later on, when I want to perform diagnostics on the O2 sensors, I need to go to this port over here. There is a special service tool from Toyota and Lexus to get a readout, but you can also make up your own by using a couple of jumper wires. And I brought my electronics kit, so I want to use a couple of plugs and make up some jumper wires to make life easy. So here's the check procedure. This is the OBD connector in the dashboard, and we have to place a jumper wire between terminal E1 and TE1. But before we do that, we have to put a car ignition on, and then connect those two terminals, TE1 and E1, and then there will be a blinking code, and this indicates a code. For instance, the example they used here, one blink followed by 2, that's 1, 2, code 12 is 3, and then 1, code 31, like it says in the text in German over here. So that's what I'm going to do now, and I'm very curious to see what comes out. Alright, let's give this a try. I brought pen and paper. I don't have the best memory, so I'm gonna write it down. Put the car in ignition. Now I have to find both terminals. There's also a label on here that says what is what. And there's 2. Yeah, we got flashes. But they're constant. But they're flashing in a constant pattern. So I'm gonna look in the workshop manual. Okay, that yielded no result, but that may also be a good thing. Now we're going into test mode. Before we can go into test mode, there are a couple of conditions the car has to meet. The battery power should be at least 11 volt. The throttle valve should be closed. The gear should be in neutral, and the climate control, the HVAC, should be switched off. The ignition should switch off. Now, once we have that, we can connect another terminal, E1 and TE2, and we put the ignition on. We have a step 4 over there. Now there should be a blinking pattern like it says here, short flashes. So once that is in order, we can start the engine, and then we go out for the drive, and it says in the workshop manual that you have to simulate the customer complaint or confirm the customer complaint. Then we get back to the workshop. Now it gets a bit unclear. Then we have to connect 3 terminals, it says over here. So I assume they leave E1 and TE2 connected all the time. That's the test and recording mode. And then you have to add TE1 to that. So I made a different jumper cable so I can connect those 3 at the same time. And once we have TE1 connected to that, we should get a fault code. And there's a wide variety of fault codes in the workshop manual. It starts at 1.2 and goes to 5.1. So it's pretty basic, but I'm really curious to see if this yields any results. As you can see, the ignition is still on. The car is already in neutral. The climate control is out. So we've done that. Switch the ignition off. Get the key out just for good measure. And now we have to connect E1 and TE2 over here. They are really close together. We should get a blinking pattern if I'm not mistaken. Yes, there are quick flashes. Now I can start the car. Okay, now it should be in recording mode. So let me get the camera out of the way, go for a test drive, and see you in a couple of minutes. Yeah, for you it will be a couple of seconds. Okay folks, the camera battery died on me. I have all 3 wires connected now. Maybe you can see it in screen. OD off and the malfunction indicator lamp are flashing. I'll zoom in, meaning that there are no fault codes stored during this test drive. So basically that's a good thing, but it doesn't explain my fuel consumption. And we have plenty of other options. As you can see, there they are flashing. Alright. Let's put the jumper wires out. Now having a fault code is of course a good thing, but now I have some diagnostics to do. So let's head over to the workshop manual and see what we can find. Alrighty folks, now it's time for Uncle Arnold reads from the Lexus LS 400 workshop manual. We don't have a fault code, but what fault codes can you expect, and what was I more or less expecting? I was expecting a fault code 26, and fault code 26 means that the mixture is too rich. And you have 25, mixture is too lean, but that's apparently not the case. Then Then there are the fault codes for the 4 O2 sensors. The first one is code 21, and that's the upstream O2 sensor for the left hand side cylinder bank. Code 27 is the downstream O2 sensor for the left hand side cylinder bank, and you can have an unexpected current or an interruption in the signal. Then to the right hand side cylinder bank O2 sensor, 28 is the upstream sensor and 29 is the downstream sensor. So those are the O2 sensors. I'll blink all of this in screen. Then you have the air volume sensor, which is a Karman Vortex sensor. I'll go into that later, maybe in the next episode. You get a fault code 31 for that, but if the air volume sensor is off or has an unexpected reading, it will immediately flash the malfunction indicator lamp in the dashboard. When you forget to connect it, it goes with an assumed value. It's done by the ECU, but it also flags immediately the malfunction indicator lamp. Alright, and there's a pressure sensor, and other than that, yeah, there are the NOx sensors. If you want to know, let me know or hit me up. I can read all of them out and blink them in screen, but it'll get very confusing if you don't read out of the codes and you want to reset all the fault codes. There is a fuse box underneath here in the engine, and you have the EFI, the fuel injection fuse. You have to pull out for 10 seconds and get it back in, and then you clear all the fault codes. You can also do that by removing the negative terminal from the battery, but like it says in the workshop manual, that will also clear the clock and all the presets of your radio. So just pull out that fuse. Okay, now the next step is I want to perform some measurements on the O2 sensors, but it's a bit hard. I have to have the car running at 2,500 RPM, which I can do, but I do want to show you the procedure for that. So we're going to open up the hood and see what we can find here. This is how you connect the jumper cable onto the diagnostic port. Look from an angle, this is the front of the car. You can see there's the oil filler cap, so you have an orientation, and this is important to know because the diagnostic port is drawn the other way around in the workshop manual. So I tried to film this before without any success. So this is how the jumper cable goes, E1 to TE1. Okay folks, my microphone battery died. The next thing I'm going to do is to check the power supply to the O2 sensors, and that's what you do. I'll get the camera up close. You get a negative terminal of your multimeter on the E1 port and use the positive terminal to measure either the aux1 port or the aux2 port. That's good. And that's good too. Well folks, these aren't the results that I expected, and on the other hand, that's good news. The O2 sensors seem to be working fine. Now there are two more O2 sensors. Those are the downstream O2 sensors, which I can measure, but if I want to measure that, there are no terminals on the diagnostic port here in the engine bay. I need to take out the ECU, and I have to back probe the ECU plug in order to see what the downstream O2 sensors read. Now, if the downstream O2 sensor would flag a rich mixture, you can be sure that the upstream O2 sensors would signal that too, and we would have had very different results than what we would have right now. So it makes no sense to start measuring on the downstream O2 sensors. So until now I don't have a clue about what the high fuel consumption or the higher fuel consumption can cause, but also I've driven very short trips, and I'm gonna do a long trip in 2 days. I'm going to Belgium with my buddy to look for a second gen LS2 he's interested in. So that'll be the first test to see what the full fuel consumption actually does. But I want to continue this video and show you what else you can do and measure in order to find out the cause of a high fuel consumption. And there are 2 more things we can check. That's the coolant temperature, coolant temperature sensor, I must say, and the air volume sensor. So we're heading back over to the workshop manual, and I'll show you what we can measure on those 2 sensors. Now in the warm-up cycle, the engine, the ECU, enriches the mixture to get the engine running smooth and get it up to operating temperature, and after a while it settles down. You can hear the car go from high idle to low idle, and when you drive you'll know that the car will stay running longer in 3rd gear and doesn't upshift into 4th gear in order to get the engine up and running. And you see the coolant gates on the instrument cluster rise, and at a certain point the car goes in low idle. Here's what you want to look for. These are the temperatures in Celsius, and on normal operating temperature the resistance should be between 0.2 and 0.4 kilo ohms, and when it's cold it should be around 2 to 3 kilo ohms with 20 degrees. I'll blink in the translation also. So let's head over to the car and show you where the thingy lives. And it's a hassle to get out, but it's over there. It's hard to get a shot of it. It's underneath the thermostat housing. It's that cable over there, or that connector over there with a yellow and green connector. And we want to get it out. You have to remove the thermostat housing and bleed all the coolant, let all the coolant out, I must say. But since I know that is working correctly, I'll leave it in. But anyway, that's where you can find it. Okay, and the next thing we can check is the air volume sensor, which lives over here. Now this is a very, very delicate device, and I know this one is working fine. I'm gonna take it out to see if it's clean, but there's nothing much to clean inside here. Like I said, it's a very delicate device, but it's also, well, not prone to go bad over time. Now I have a broken one on my workbench, and I want to explain a little bit about how this works. Okay folks, welcome to a class with Arnold. This is a Karman Vortex air volume sensor that I took apart. This is one I ordered for my previous LS back in 2015. This came in from China, but it was full of water. It wasn't working, so it didn't help me, but I took it apart just out of curiosity. This part goes in here and it sticks out from the bottom. This protrudes into the air intake. What we have here is a so-called vortex generator. This is a triangular shape in the front that creates a vortex. There's a slit in between, not sure if it shows, and on the back side, hope it shows on camera, there's a small slot, and there's a second slot on the opposite side. There it is, and on top in this slot is a hole that leads to this part over here, this rectangular part. A vortex are a lot of small waves, vortexes, name says it, and waves of course aren't two-dimensional, they are three-dimensional, and a part of this wave is fed through this tiny little hole in top of this slot. It's very hard to show, but it goes into this housing, as does the one on the opposite side. Now here's a strip of metal in here, and it's slightly flexible, and when the air starts to stream it creates waves, and this mirror in here will start flexing, will start moving up and down in a sort of wave motion. This is an LED, it emits lights to the mirror, and this is a photo optic cell. I can't get to the correct term right now, I'll blink it in screen, that picks up the signal. So it sees a fluctuating signal, and that tells it how much air, how much volume is going into the engine. It isn't a mass airflow meter, it just measures the volume. And this thermistor over here measures the air temperature, and inside the ECU itself is an air pressure meter, and that's how this ECU calculates the amount of air coming into the engine and adjust the fuel ratio to that. Anywho, this LED, this photo optic cell, are soldered to this flexible circuit board on top inside the housing, and inside here is a small PCB, and what this does, this translates the signal which it measures to ready to serve signal for the ECU to the connector over here. You can see it's connected over there. Now this was full of water, so there is some water damage in here, but there aren't a lot of moving parts. It's just this mirror inside this housing. When this doesn't work, or when any of this doesn't work, it'll immediately light the malfunction indicator light in the dashboard, and I know that the air volume sensor in my car is good. But what can happen is that these slots and these tiny little holes in here get clogged up. Then you have to find a way to clean it. You can blow air in there, because that most likely will damage the mirror inside here, and air sensor cleaners are also a no-no, because it can damage the materials. This is a very delicate part, but actually it's very fail-safe. It's like the ride height sensors. There aren't a lot of moving parts. Everything is photo optic. Now let's head over to the car, get my air volume sensor out, and see what it looks like. I like to use a soft brush. This part is aluminium, so it can have a little bit of blooming. I want to brush off 3 Phillips head screws, and the part number for this is 22204-42011. So let me get it out. Careful, Arnold. It is dirty. I did not expect that. Let me get it on the bench and give you a close-up view. There is one thing you could also check. I noted when I was cleaning this perimeter, this round surface, there is a seal in here, and the seal seems to be a little bit brittle. Now what can happen if this seal is brittle and starts to leak, you'll suck in air through here, and that immediately disturbs the vortex, so you get a false reading. And like I said, I have the old one, and the seal in there of the older one looks much better. So what I am going to do is replace the seal, but we have to get the old one off first. I don't have a nice pick to do that. Looks a little bit better, so I'm gonna use that one. I'm gonna clean it first. And one thing, never use brake clean the proximity of such a sensor, because if you have any sputters and it gets in there, a brake clean always leaves a residue. It's very nasty stuff. Let's put the new O-ring on. Give it a final inspection. Everything looks okay. And also, besides not using brake clean, never use microfiber towels, because it always leaves some fibers behind. Just blow it off a little bit. Okay, now it's good to go back in. So all 3 screws are tight. Connector is reconnected. I put some electro protection spray in there, so everything is said and done. So these are the steps you can follow to investigate a fuel consumption problem, either when your mixture is too rich or too lean, if you have any of those fault codes. In addition to this inspection, if you have a lean mixture, you also want to check for leaks in this part over here, in the intake manifold. Everything past the air volume sensor, so there are these lines in front over here you want to inspect, and these hoses are now almost 30 years out, so they are prone to drying out, getting brittle and getting cracked. So that's what I did. I checked everything, but I also did when I worked on the car. So those are the things you can check. It's time for me to close up hood now. It's evening already and I'm heading home. So I didn't find a real cause for the fuel consumption problem, but like I said, I've only driven short stretches, did a few high-speed runs to check, and so the car is filled up at this moment. And like I said, I'm going on a road trip in 2 days and I want to see how the car behaves then. If it still has a high fuel consumption, I think I'll investigate deeper into that and do a thorough investigation, but all of that will be off camera, and if I find anything wrong, I'll let you know in the next episode. So that's my plan for now. Now you know how the fuel system works and how the air mixture control works in the first gen Lexus LS 400, and I hope you liked following me along. If you did, please give me a like, consider subscribing to the channel, leave a comment if you have any further questions. I like to help folks out who are working on these first generation Lexus LS 400s, and it's sort of my hobby to keep these cars up and running. So for now, I'd like to thank you for watching and I hope to see you on the next one. Bye!